Alrighty. Good morning, everybody. Welcome back to Game Theory. Plan for today is we're going to finish our discussion of the normal versus the extensive forms of a game, and then from there we're going to talk about information sets and information partitions that a player can have during a game. Like I said in my email this morning, I'm canceling my afternoon office hour today, mainly because I need to get home before the snow gets really nasty and the roads get really bad. Apologize for that. Tomorrow, I will have office hours tomorrow. I'm not sure if they will be in person or by Zoom. So it kind of depends on what the weather ends up looking like kind of tomorrow morning, tomorrow afternoon and stuff. I may end up having to stay home for the day. I'll send you all an email either tonight or tomorrow morning to let you know on those office hours. And if I end up doing it by Zoom, I'll send you the information on how to access all of that. As far as homework goes, like I said, moving quiz 2 to Friday, just so everybody has a chance to take it on the same day. Didn't want anybody to have to come in just for the quiz if they're felt uncomfortable with driving, etc. Any questions or comments before we get started for today? All right. As for the joke of the day, I have a video for you.
Tonight's forecast. A freeze is coming.
Allow me to break the ice.
You are not sending me to the cooler. Freeze well. What killed the dinosaurs? The Ice Age! Stay cool, bird boy. Let's take some ice.
Show some mercy.
I'm afraid that my condition has left me cold to your pleas of mercy. All right, everyone. Chill. It's a cold town. Cool party. Can you be cold, Batman? Yeah. To perfection. Revenge is a dish best served cold. Winter has come at last. Freeze. Freeze. Ice. Freeze. Icy winter forever. Frozen. Icy. Freeze. Winter ice. Ice. Freeze. Winter. Winter. Freeze. Cold. Frosty.
Okay, so that was a clip from those were all from Batman and Robin. A great Batman movie, got terrible reviews. It's not actually a very good movie, but it's a great movie if you want to see, if you love terrible puns about from Arnold Schwarzenegger about being cold. Okay, so I'm going to make sure this is still recording. Yes, it's okay. So when we left off last time, we had talked about the two different ways that we can visualize a game. The normal/strategic form of a game, which we've kind of been working with all semester, where you have to sort of make a table of your payoffs and all of this that correspond to each strategy profile that a game could take. And we also saw this extensive form of a game, or the game tree, where we kind of lay out from left to right who's taking what actions and what are the payoffs associated with each action at the end. So in this game that I asked you all to look at the end of class last time, we saw that Bank is moving first, and Bank has a choice to either forgive or to collect. And then based on what Bank chooses, Business, if Bank forgives, Business has one of 3 options, each leading to a different set of payoffs. And if Bank collects, Business only has the 2 options of opening and collapsing. So with that in mind, I'd asked you at the end of class last time to construct what might the normal form of this game look like. So I thought it would be good to start out today by looking at that. I'm going to put my bank strategies are going to be my rows, and business strategies are going to be my columns. How many different strategies can Bank have in this game? bank only gets to do one of two things, just forgive or collect. They don't have any information about what business is going to do at the time they make their decision. So bank strategies in this game are going to be to forgive and to collect. Give myself a little more room. What might some of the strategies for business look like? Can anybody give me a strategy that business could choose to employ in this game? Yeah?
Open no matter what.
It's all open regardless of what bank does? That's certainly something that business could do. If bank forgives, business could choose open. And if bank chooses collect, business could also stay open. And the payoffs associated to that would be if bank forgives, business stays open, would be 0-4. If bank collects, business stays open, it would be 5-3. Are there any other strategy? What other strategies could a business employ here?
They could choose to collapse no matter what.
They could choose to collapse no matter what, because that's an option either way. And then let's see, if bank forgives, business collapses, that would be a payout of 0-0. If bank collects, business collapses, that would be a payout of 4-4. So I think that kind of constitutes the two strategies that business can choose from that are just, I'm going to do this one action no matter what bank does. Unfortunately, I don't think business can have a strategy that's just buy no matter what, because depending on what bank does, business may or may not have the option to actually buy. So what might a strategy for business look like that would involve buying? Yeah?
You can buy if the bank forgives and then open if it collects.
Aha! So in other words, you could have a sort of conditional strategy that's dependent on what bank does, where if the bank goes down this path of going down the forgive route, business can choose buy. But if bank does something other than forgive, if they collect, business would have to have a different strategy. So we could indeed have something like buy if forgive, open if collect. Which, let's see, if bank forgives, then that would result in the business buying, and that would have a payoff of 0-8. If bank collects, that would result in business opening, which would lead to the 5-3 payoff. What other strategies we got for business here? Yeah?
You could buy if they forgive or collapse if they collect.
The other option that involves buying, that if bank forgives, business could choose buy, but if bank collects, business could just choose to collapse. So I'm going to denote that with buy if forgive, collapse if collect, which, let's see, would result in 0-8. If the bank forgives and if the bank collects, the business would collapse. And we get a 4-4 payoff. Any other? David?
They could collapse if they forgive, but open if they collect.
Okay, do something like sort of I'm not going to say an anti-mirror strategy, but say if the bank forgives, did you say open if forgive, collapse if collect, or the other one?
Collapse if forgive and open if collect.
Okay, as I said, those are gonna be the last two strategies. We're gonna need both of those. So we could have collapse if forgive, open if collect, and finally we could have open if forgive, collapse if collect. And let's see. So this would result in forgive collapse, which would be 0-0. This would result in collect open, which would be 5-3. And here this would be, let's see, the bank forgives, so business will open, so 0-4. Collapse if collect would result in a -4 payoff. And so our normal form ends up having 2 different strategies for bank, but 6 different strategies for business. All accounting for the fact that there's 3 options if the game goes to this node for business, and 2 options that business can take if the game goes to this node. And these 6 different strategies will account for every possible choice that business could make at the start of the game that is dependent on what bank does. 2 strategies that don't care about what bank does, and 4 different conditional strategies that do. Any questions or comments about how we came up with this table? In general, we can't just have a single column here that's just for buy, like we did for open and collapse, because buy isn't always an option that you take. So buy can only appear as part of conditional strategies here. Did anybody find any equilibrium states in this game? So let's maybe start with dominant strategy equilibrium. Does bank have a dominant strategy here? Tom?
Collect.
Yeah, I think collect is going to be dominant because if business chooses open, 5 beats 0, 4 beats 0, 4 beats 0 in this column, 5 beats 0, 4 beats 0, 5 beats 0, 4 beats 0. Is collect going to be weakly or strongly dominant column for bank?
Strongly dominant.
I think it's going to be strongly dominant because in all 6 cases, no matter what business does, collect will always give bank a strictly greater payoff than forgive would. So bank is going to have a strongly dominant strategy of collect. How about business? Business has 6 different strategies that they can choose from. Are any of them going to be dominant? Yeah?
They have a weekly dominant strategy of buy if forgive and open if collect.
So this third column here? Well, let's see. If they choose this strategy and bank forgives, they're going to get a payoff of 8, which is bigger than 4, bigger than 0, ties with 8, bigger than 0, bigger than 4. So buy, forgive, open, if collect would give a tie for the greatest payoff if bank chooses forgive. If bank chooses collect, on the other hand, they'll get a payoff of -3, which is ties with this, better than this, which is the strategy that tied with it in the first row. Ties with that, better than that. I agree. I think this is going to be a weakly dominant strategy for business. Weakly dominant because it always at least ties every other strategy, and in at least one case does strictly better. So I think we are going to have a dominant strategy equilibrium here, where the bank chooses collect, and business is going to choose the conditional strategy of buy it, forgive, open, and collect. How about iterated dominance equilibrium? Does this game have any of those?
It has collect, comma, buy it, forgive, open, collect.
How do you know that?
Because we know that if it's a dominant strategy equilibrium, it has to be a iterated dominant strategy. It has to be an iterated dominant strategy equilibrium as well.
That's a mouthful to say. So yeah, absolutely. We know that every equilibrium of this first type has to also be the equilibrium of the second type as well. So that's automatically going to make collect, comma, buy it, forgive, open it, collect, not only a dominant strategy equilibrium, but also an iterated dominance equilibrium. And I think that's going to be the only one here, because since bank has a strongly dominant strategy of collect, any iterated dominance equilibrium is going to have this appearing. And if we start crossing out columns for business, there's not going to be any way to ever cross out this column because this is never going to be weakly dominated or strongly dominated by another strategy. So this is the only possible iterated dominance. Finally, how about Nash? Or, yes.
For iterated dominance equilibrium, what if you like eliminate the bank's forgive option first and then just look at collect? Isn't it sort of a tie between open, the one that we have up there, and collect if they forgive, or open if they collect?
Yeah, so I don't want to actually cross this out, so I don't have to redraw it. But let's say we crossed out this top row, which if we were looking for iterated dominance equilibrium is something we would certainly have to do at some point. We could then say, well, we could cross out collapse, because -4 loses to -3 here. We could cross out this one column. We could cross out this column. But then I think we would be stuck with 3 separate cells. We'd be stuck with this cell right here, this cell right here, this cell right here. And since we have 3 different cells at the end, anything that's an iterated dominance equilibrium has to come from being a single cell that's at the end of a crossing out rows and columns thing. So the fact that we end up with 3 separate cells that are left, and none of them are ones that we would be able to cross out at all, tells us that starting out by crossing out forgive for bank isn't going to lead to any iterated dominance equilibrium. Quick question. I think in one of the videos from last week when I was out sick, we had something like that occur where one way that you could start crossing out rows and columns left us with 2 separate cells and no way to distinguish between them. So that just would mean that that choice of crossing out rows and columns in that order just doesn't lead to anything. Doesn't mean that those cells couldn't potentially be iterated dominance equilibria by crossing out rows and columns in a different order. Just not by doing it in that order, in whatever order we would do it there. So here, if we wanted to get this as an iterated dominance equilibria, if we didn't already know it had to be that from checking for dominant strategy equilibria, we would have to do something like cross out these 3 columns right away because they're all weakly dominate. Well, basically we could cross out every column right away because this column either weakly or strongly dominates every other column. And once we're left with just this column, we would cross out the forgive row because 0 loses to 5. We would cross out the forgive row because we would cross out the collect. What am I trying to say?
Would we cross out?
8 beats -3, so we would. 5 beats 0, so we would cross out the forgive row. I'm sorry, I'm confusing myself up here at the board. Yeah, so I had it right the first time. 0 loses to 5, so we would cross out forgive at that point once we're left to just this column, and we would only be left with this one right here. How about Nash equilibrium? Is there anything we know has to be a Nash equilibrium without having to do the boxes and or arrow method? Gary?
Aren't all iterated dominant equilibrium Nash as well?
Yeah, every iterated dominance equilibrium has to automatically be Nash, which is going to tell us that this thing, which we knew from the start was a dominant strategy equilibrium, automatically is going to have to be both an iterated dominance equilibrium and a Nash equilibrium as well. So we're going to get collect, buy it, forgive, open it, collect, is going to be a Nash equilibrium. We should still go through the box and or arrow method. Here I'm going to do the box method, just to make sure there aren't any others that are Nash but not the other 2 types, which is certainly something that's possible. So let's see. If bank chooses forgive, business's best payoff is going to be from buying. So I'm going to put a box here, here, and that's it. If bank collects, business's best possible payoff is going to be
Shouldn't those be dotted boxes?
Oh yeah, you're right. It should be. Doesn't really matter. As long as we know that to draw a box around it, but you're right. Using the method we've talked about, we should actually have that be dotted. Let's see. If bank collects, I think the best payoff that business could hope to get is going to be -3. So I'll draw dotted boxes around the -3s. Let's see. If business chooses open, bank's best payoff is from collect. Business chooses collapse, bank's best payoff is from collect. Look, collect is a strongly dominant strategy, so it's always going to get a solid box. And with that, do we have any other Nash equilibria? Yes, the answer is yes. What other Nash equilibria do we get? Isabel? Collect open? Any others?
Collect and then collapse it, forgive, open it, collect.
Yeah. Collect, and then collect and forgive, open and collect. I think are all going to be Nash. Because those are all going to be cells that have doubled up. By the way, what do these three strategy profiles all have in common?
They all result in opening.
Yeah, they're all going to result in the same action profile. Where if we were to look at the action profile that results, bank is going to collect, and then all three of these strategies for business are going to result in business opening. Because the only difference between these three is what business would decide to do if the bank happened to forgive. Well, if the bank's not forgiving, if the bank's collecting, then it doesn't matter what business would do if the business forgave in terms of action profiles. All of these are going to result in the business ending up opening if this were to occur in an action game. Meaning all three of our Nash equilibria are going to occur looking at the game tree as a result of kind of going down this path right here. Any questions or comments? All right, so that's going to do it for this packet. So next up, I'm going to talk a little bit about something we touched on last class, which is how is the game tree going to behave differently, and how is the game in general going to behave differently if the players have different amounts of information available to them. Okay, sure, I'm angry. So, first of all, I want to talk about information sets. So we've sort of been throwing around this term informally so far throughout the semester, this term which is just information. Like, what does it mean for a player to have information about in a game versus that's embarrassing. Versus having a player not have any sort of information is better anyway. So we're actually going to kind of come up with a definition now for what information is. So in general, we're going to say that a player's information set is basically, let's suppose that it's that player's turn during a game. Does that player know, let's say for Jones and follow the leader. So the same game we kind of talked about last class, where Smith chooses large or small, Jones chooses large or small accordingly, and that leads to a payoff. One way we could say that Jones has information in this game is to say that Jones always knows on their turn what Smith did. Meaning Jones knows if they're at the node J1 because Smith chose large, or if they're at the node small, or if they're at the node J2 because Smith chose small. So an information set that a player can have is basically a set that consists of all the nodes that the game could potentially be at based on what that player knows at that given point in time. So information set is the set, in the packet it says sess, I should not say that, of different nodes in the game, tree. They know could be the actual current node. During a game. At any point in time. So, in order to analyze information sets, if we were to look at this game, Jones' information set is always going to have just a single node. If Smith chose large, Jones' information set is just going to have J1 in it, because Jones knows that this is where the game's at and their decisions will act accordingly. On the other hand, if Jones knows that Smith has chosen small, then Jones would know that the game has to be at the node J2, and so their information set would only have that single node in it. So we're going to add a slight twist to this game. We're going to assume that Jones now has to make their decision of large or small without knowing what Smith has already chosen. And to denote that, I'm going to draw sort of this dotted circle around J1 and J2. Where the dotted circle is going to say, on Jones's turn, Jones doesn't know which node he is at. So, anytime you draw a dotted circle around nodes in a game, that means that the player whose turn it would be to make a decision at that node, doesn't know which of the nodes it's at. I like to think of it as sort of being like a fog of war. We're drawing this sort of cloud around our nodes in which it's sort of foggy. Jones can't kind of see what's going on. He doesn't know where he's at in the course of the game. So let's say for the sake of argument that we're going to assume that Smith chose large and it's Jones's turn. in this game right here. Which nodes would be in Jones's information set? Meaning, if we're playing this game right here, Smith has made a decision of choosing large. What nodes could the game potentially be at according to what Jones knows? At the point where Smith has chosen large.
Could be at J1 or J2.
Yeah, there's a cloud here. Jones doesn't know what Smith chose. So Jones knows that it's his turn to make a move, but he doesn't know if he's at the node J1 where Smith has chosen large, or if he's at the node J2 where Smith has chosen small. So Jones's information set at this point in the game is going to consist of two separate nodes, J1 and J2. Because as far as Jones knows, the game could currently be at either one of those two nodes. How about at the same point in time? Let's say Smith has chosen large, and now it's Jones's turn in this game. What's Smith's information set look like? In other words, according to what Smith knows about what's taken place so far, what would, where did I put this? What nodes could the game potentially be at? Okay,
J1.
just J1? Even though I drew a cloud around J1 and J2?
I mean, Smith knew what he picked.
Yeah.
We would hope.
Well, it's just like, I'm going to choose large and immediately forget about it. If that was the case, maybe Smith should no longer be the CEO, despite his name being in the name of the corporation. But yeah, Smith, just because we drew a cloud around J1 and J2, this is a cloud for Jones. This cloud means that since these are nodes corresponding to Jones needs to make a decision, that's going to tell us that Jones will have to, that Jones doesn't know where the game is at. But if Smith chose large, Smith knows exactly what node the game's at. If he chooses large, he's going to know that the game's at J1. And so Smith's information set is just going to consist of the node J1. Because out of all the possible nodes that the game could be at, according to Smith, there's only one possible node. Smith chose large, it's got to be at the node J1. But if Jones doesn't know what Smith chose, then Jones's information set is going to contain both J1 and J2, corresponding to the fact that Jones, according to what Jones knows, he just knows that Smith made a decision and it's his turn. The game could be at either one of these nodes, potentially. Any questions or comments about that? So this is kind of interesting to me, because Jones has a bigger information set than Smith does. Does that mean that Jones has more information about the game than Smith does? According to our colloquial understanding of what information would be? Yeah?
Jones would have less information because he has less certainty because there are more options to what reality could be.
Yeah, exactly. And this is a little bit counterintuitive, but the fact that Jones has a bigger information set actually means that Jones has less information about where the game is at. You can say that in general, a larger information set means less information about where the game could be at. less certainty about which node the game's at. And so when we talk about, whenever we talk in a game about a player having more information or less information than another player, what that really means is, at that given point in the game, what is the size of that player's information set compared to another one? If you have more elements in your information set, then there's more possibilities of where the game could be, and thus less knowledge about or less certainty about, I know where exactly in the game tree we're at. I know what's going on here. Any questions or comments about looking at information sets? If Smith had chosen small and it was Jones's turn instead, Jones would still have the same information set, but Smith would only have J2 in it instead of J1. And if we're looking at the information set of both players at the very start of the game, it would just have S in it for both, because it's Smith's turn, both players know it, neither has any more information than the other yet. Okay, so with that in mind, I'm going to talk a little bit about something called an information partition of a game. So an information partition is similar to an information set. It basically says, at a given point in time during a game, what are all the different information sets that a player could potentially have based on what's taken place so far? So let's say this. At a given stage in a game, we can talk about a player having an information partition. And their information partition is a partition of all possible nodes the game could be at to different information sets. So here we have a word that we haven't quite talked too much about, partition. If I were to tell you I wanted to partition something, well, what do you think that means? Like if I told you I wanted to partition up all the students in this class, what would you think I'm talking about? Okay?
Dividing or separating them.
Yeah. So in general, when we talk about a partition of something, colloquially we usually talk about separating something into like smaller groups. Like I could partition the class into 5 different or 6 different columns, for instance, and say, all right, here's a group, 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 there's a group. Sorry, you all got it there instead of here. Basically saying that a partition is just a way of dividing something up into smaller subclasses. So when we talk about an information partition, what we're really saying is at a given stage in the game, like let's say Smith has made their decision, the information partition for each player is going to consist of all the different possible information sets a player could have based on where they know the game could be at. So as an example, let's say we're at the point in the game where Smith has made their decision. We're not going to specify what that decision was. We're just going to say that Smith made a decision. And what I would like to do is talk about, without specifying what that decision is, what are all the different possible information sets that a player could have at that point in the game. So we'll start with, let's start with Smith this time. So what can we say that, let's say Smith made his decision. Smith had to have made one of two choices. Their decision could have been large or their decision could have been small. Madeline, let's say Smith had chosen large. What would Smith's information set look like if Smith had made the choice of large? Yeah, it's just going to have J1 in it. So depending on what Smith has done so far, one information set that Smith could possibly have is their information set could just look like this, the set containing J1. And that's going to be their information set if Smith chose large. On the other hand, let's say that Smith had chosen small instead. What would Smith's information set be at this point in the game, where it's either J1 or J2, if Smith had chosen small? What all would be in Smith's information set? Yeah?
J2.
Just J2. So Smith, again, knows exactly where the game is at in this case. Their information set is just going to have J2. That'll be their info set if Smith goes small. And the set, this bigger set here, the set containing J1 and the set containing J2, is going to be Smith's information partition at this stage in the game, basically saying, what are all the different information sets that Smith could potentially have at this point in time, based upon all the different decisions and events that could have happened so far. So in this case, only one of two things could have happened. Smith chose large or Smith chose small. If Smith chose large, here's Smith's information set. If Smith chose small, here's Smith's information set. And so in other words, we have a set of all possible information sets. Let's contrast this with Jones. Let's say we're at the point in the game where Smith chose either large or small. What would Jones's information set look like? Great. In both cases? Yeah, because there's a cloud around these two nodes. So in other words, Jones if Smith chose large, as far as Jones knows, their information set would consist of J1 and J2. On the other hand, if Smith chose small, Jones's information set would be the exact same. Consists of J1 and J2. No matter what's happened so far, Jones is going to have information set consisting of both nodes, J1 and J2. So we're going to say this is the information set if Smith chose large or small. And so, in other words, Jones can only have a single information set no matter what's happened so far. Jones's information set will have to consist of these two nodes, J1 and J2. On the other hand, Smith is could have two different potential information sets at this point in time. An information set if they chose large, and a different information set if Smith had chosen small. And so information partition is basically just going to be this idea of, it is basically just going to look like this. The set of all potential information sets. You notice something, J1 and J2 both appear exactly once in each information partition. That basically corresponds to the fact that Smith and Jones know that the game has to be at one of those two nodes, J1 and J2. Smith has a little bit more information, meaning that they can kind of divide further and say, I know exactly that it's at J1, or I know that it's exactly at J2. Jones, on the other hand, doesn't have any way to sort of distinguish between these two different nodes. So these are going to appear in the same information set in their information partition. Any questions or comments about information sets versus information partitions? All right, I have an activity for you then. Let's say, for the sake of argument, we're going to make a new game here. And I already kind of drew it out in your packet, what that game might look like. Where this time, instead of, let's say that Smith made their decision, Jones makes their decision of large or small, but after each player has made their decision, let's say Smith has the option to change their mind. Meaning Smith is going to have a second turn in the game. And I'll continue drawing. You can see like the finished version of what that would look like in your packet. But let's say that Smith has the option of choosing change their mind from large to small or vice versa, or stay the course and stick with their original choice. My challenge to you is if each player doesn't know the other player's initial decision, at the point in the game where Smith has to make their decision of if they're changing their mind or not, what would each player's information partition look like? So in other words, if this is the point in the game we're at, where Smith has to decide whether or not they're going to change their mind, and neither player has any information about what the other player has chosen so far, what would Smith's information partition look like? What would Jones's information partition look like? Let's go ahead and take a couple minutes and talk to your neighbors and see if you can determine what the information partition would look like at this point in the game. And I'll give you a hint. There might be some clouds present in this game tree that I didn't actually draw in. Did I give you your question, Paul? Yes. So you might have to draw in another cloud or two in order to make that appear. All right. I've given you enough time to think about this, by which I mean we're actually out of time for class today. So what we're going to do is on Friday after the quiz, I'll actually give you time to think about this with your neighbors. What would the information partitions look like? And we'll talk about it in a couple different scenarios. And then from there, we'll go on to talk a little bit about information partitions in general and what does it mean to refine or coarsen your information partition. All right, hope you have a good rest of your day. Stay safe if you're traveling. Otherwise, have fun out in the snow, do whatever, have a blast, I don't care. As long as you stay safe and have fun, and don't stress yourself out. Have a good one.